Exploiting 4G mobile user cooperation for energy conservation challenges and opportunities. 6 pages, October 2013. IEEE Wireless Communications. Bachar Hamdawi, Tamara Al-Shamari, Moshan Gozani. In recent years, there has been a rise in mobile users, which has led to an increase in popularity of mobile applications, number of mobile devices, and the type of things it can do. Dependency of such devices to access and receive online services have resulted in the emergence of new services. Devices face energy conservation problems such as a decrease in battery life. In this video, we will be focusing specifically on exploiting user cooperation as a way of conserving energy to make effective use of available energy resources. There are 4 potential ways for reducing energy consumption for mobile users, such as channel diversity, user cooperation, power conservation, and reliance on nearby nodes to relay data. However, some challenges such as users' unwillingness to cooperate, not seeing benefits and rewards, security and privacy concerns, resource limitation, and discouragement from misbehavior. To support user cooperation, incentive mechanisms, enforcement strategies, and relay section approaches are essential.
In incentive mechanisms, nodes will be rewarded for their help. Source, destination, or both will be charged for the relaying service. There are 3 approaches to implement the charging, mainly cost paid by source node, destination node, and virtual bank. Cost paid by source node or destination node are similar to each other. In source node, the packet is forwarded with sufficient virtual currency, whereas in destination node, it is the node that pays the forwarding cost. In source node, each intermediate node deducts some virtual currency as a reward for forwarding, but in destination node, the intermediate node buys the packet from the previous node for some virtual currency. Advantage of source node is it can reduce risk of malicious attacks, but it is the opposite for destination node. However, these methods are disadvantages to the source and destination nodes because they are the only ones paying respectively. Last approach requires a third party, such as a virtual bank. When packets are forwarded, the node keeps a signed receipt which is generated and signed by the source and submits it to the virtual bank. Upon receiving it, the bank charges the source node and rewards the intermediate nodes. An improvement to the aforementioned approach would be to generate check per route instead of check per node. Ways of submitting the check to the virtual bank depends on the communication mode. Hybrid mode means at least one base station is involved and is responsible for submitting, and ad hoc mode means nodes communicate without the need of a base station, and it is their job to submit the check. A node can be randomly selected and changed to reduce the risk of collusion.
Incentive mechanisms alone are not enough for promoting cooperation. In some cases, users may seek and receive relaying service from other users, but refrain to help others. To prevent such issue, the use of reputation value (RV) to identify selfish node in the network could be adopted. When the node carries out the forwarding service properly, its RV will increase. However, if the node fails to do so, its RV will be decremented. Once the RV of a node reaches a predefined threshold, its relaying service privilege will be removed. The 2 approaches for this strategy are the first-hand reputation and the second-hand reputation. In the first-hand reputation, each node listens to its neighbor's transmission in order to decide if its neighboring node is trustworthy. The drawback of this scheme is high overload. In the second-hand reputation, nodes exchange information with one another, and if a node observes that another node does not carry out the forwarding task rightly, it reports this misbehavior to the rest of the network. The drawback of this scheme is the huge amount of storage needed, high network traffic, and the increase in computation of each node.
In this section, we are going to discuss about how relaying nodes should be selected. There are 2 main selection approaches. First is the single relay selection. In this approach, the sender will aim to find the best relay node that meets certain performance criteria. Second is the multiple relay selection. In this approach, instead of just finding one best relay node, we will find a set of relay nodes that give us the best performance. So what is the selection criteria? We will select the node that gives us the maximum received signal to interference plus noise ratio, and nodes that are nearest to the base station, and nodes that can perform the forwarding task with the least energy cost.
In this video, we have talked about the 3 essential elements of user cooperation, advantages and disadvantages, and possible techniques to improve networks. In the future, we can work towards energy efficiency. We can also build comprehensive frameworks. Harpreet Mingen, Wadia, Rongtie, Izzat.